In this question statement, consider a 150 watt lamp. The filament of the lamp is 5 centimeter long and it has a diameter of 0.5 millimeter. The diameter of the glass bulb of the lamp is 8 centimeter. So you have to determine the heat flux, which is in watt per meter square. Number one, on the surface of the filament. Number two, on the surface of the glass bulb. And you have to calculate the cost per year to keep that lamp on for the 8 hours a day every day if the unit cost of electricity in that particular area is $0.08 per kilowatt hour. Let us just try to understand this question statement with the help of this diagram. So this is a bulb and you have to calculate the heat flux first of all at the filament, right? And the dimensions of the filament are also given, which is the length is 5 centimeter and the diameter of the filament is 0.5 millimeter. So the second thing is you have to determine the flux at the surface of this bulb. So the bulb diameter is also given, which is the diameter 8 centimeter. So keep in mind that all the units are different, like some are in centimeters, some are in millimeters. You have to convert all the units into meters. So you have to solve this problem in 3 different parts. First, you have to determine the heat flux for this filament, and the second, you have to determine the heat flux for the whole surface of the bulb, and the third is you have to determine the cost of this bulb, a cost of electricity for this bulb. So let us just try to solve this problem, that the filament of a 150 watt lamp is 5 centimeter long and has a diameter of 0.5 millimeter. The heat flux on the surface of the filament and the heat flux on the surface of the glass bulb and the annual electricity cost of the bulb are to be determined. These are 3 things that you have to determine. The assumptions that we take is the heat transfer from the surface of the filament and the bulb of the lamp is uniform. So the first part is of this problem is to determine the heat transfer surface area and the heat flux on the surface of the filament. So this is the surface area of the filament and the dimensions are given in the question statement, that is 5 centimeter long and 0.5 millimeter the diameter. So you have to convert it into either meters or centimeters, but the units must be consistent. So it should be either in meters or it should be in centimeters. So this is the diameter of the filament. So after putting all the values, you will get the surface area of the filament, which will be equal to 0.785 centimeter square. So the heat flux can be calculated by dividing the rate of heat transfer by the surface area. So the rate of heat transfer is given, which is 150 watt, and if you divide it by the surface area of the filament, so you will get the flux, which will be equal to 191 watt per centimeter square. If you convert it into the meter square, so it will be equal to 1.91 multiplied 10 raised to the power 6 watt per meter square. Either you convert the units in the previous slide when you were calculating the area, either you can convert this unit into meters over here, or you can convert the units into meters after calculating the overall flux of the filament. So the second part is you have to determine the heat flux on the surface of the glass bulb. So the area, surface area of the glass bulb is given here. The formula is pi d square, and the diameter is given in the question statement for the glass bulb, which is 8 centimeter, and after putting the values you will get the surface area of the bulb, which is 201.1 centimeter square. So the rate of heat transfer is given is 150 watt. If you divide it by the surface area, you will get the heat flux at the surface of the glass bulb, which will be equal to 0.75 watt per centimeter square. And if you convert this into meter square, so you will get the value of the heat flux at the surface of the glass bulb, which will be equal to 7500 watt per meter square. So the third thing is you have to determine the amount and the cost of electricity consumed during a 1 year period. So the total amount which is basically consumed in 1 year can be calculated by multiplying the rate of heat transfer, which is 150 watt or 0.15 kilowatt, and the bulb is basically on for 8 hours a day. If we multiply it with 365, which is the whole year, and we will get the 438 kilowatt per hour is the electricity consumption for 1 year, right? And if we multiply this, the electricity consumed per year, with the unit cost, we will get the annual cost of electricity consumption, that is $35.4 per year. That is the answer of the third part, in which we have to calculate the amount and the cost of electricity consumed during 1 year. This is the electricity consumed during the 1 year, and this is the amount that we have calculated here, that is $35.04 per year.